Welcome to The Explainer. Today we're going to tackle a word you hear thrown around all the time. Algorithm. What does it actually mean? We're about to find out, and hey, by the end of this, you'll even be able to build one yourself. So, let's just dive right in.
Okay, so what in the world are we looking at here? It kind of looks like a total mess, right? Just a jumble of commands, questions, and words with no obvious order. But here's the thing. Think of it as a puzzle. Our goal, right now, is to take all these scattered pieces and assemble them into something that makes perfect sense.
Section 1. A logical puzzle. Yeah, like any good mystery, before we can even think about solving it, we've got to examine the clues. So let's do just that. We're going to zoom in and inspect each one of these pieces to figure out exactly what it does. Section 2. The basic building blocks. All right, let's isolate each type of command we saw in that jumbled mess and really define it. We're going to build our understanding one piece at a time. First up, we've got something called a terminator. I know, it sounds a little dramatic, doesn't it? But it's actually super simple. Think of it like a recipe. You need to know when to start cooking, and you definitely need to know when the dish is done. A terminator just gives you those clear start and stop points. And in our puzzle, those pieces are literally the words start and stop. They're the bookends for the entire process. They tell us exactly where the instructions begin and where they end. Simple as that.
Next up is input. And if we're sticking with that recipe analogy, the input is just your ingredients. You know, you can't bake a cake without flour and sugar, and an algorithm can't solve a problem if it doesn't have its raw data to work with.
The piece in our puzzle reads, input, num1, num2. All this means is that our recipe needs two ingredients to get started, in this case, two numbers. We're just calling them number 1 and number 2. Okay, now for what I think is the most dynamic part of this whole puzzle, the decision. This isn't just another command, it's a question. It's the point where the process has to actually think and choose which direction it's going to go next.
The decision in our puzzle comes down to this one simple question. Is number 1 greater than number 2? The entire outcome, everything that happens from here on out, hinges on the answer.
So that one question creates a fork in the road. If the answer is yes, the algorithm goes down one path. If the answer is no, it goes down a completely different one. And each path leads to its own very specific outcome. And finally, that brings us to the output. This is the whole point of the recipe, right? It's the finished cake, the solved problem. It's the final answer that this entire process was designed to produce. It's the prize at the end.
So our puzzle has two possible outputs, and now they make perfect sense. If the answer to our question was yes, the algorithm prints num1 is largest. If the answer was no, it prints num2 is largest. See how that logic flows?
Section 3. Assembling the flow. All right, we've done the hard work. We understand what each piece does. Now, it's time to put them all together in the right order. So, let's assemble it. 1. We start. 2. We get our input, those two numbers. 3. We ask the critical question, is the first number bigger? 4. We follow the path based on that yes or no answer. 5. We print the result, whichever number turned out to be larger. And 6. We stop. And look at that, a perfect logical flow from beginning to end.
So here's the crucial point, the big aha moment. What we just did, taking those jumbled commands and putting them into a logical step-by-step order to solve a problem, well, we've just built an algorithm. That's it. That's what an algorithm is.
Section 4. Why this recipe matters. So we built a simple little algorithm to find the larger of two numbers. Big deal, right? But why is this fundamental idea so incredibly important in our world today?
Because at its very core, an algorithm is simply a clear recipe for solving a problem. Sure, our recipe was simple, but this exact same logic, input, process, decision, output, is the foundation for solving some of the most complex problems imaginable.
Seriously, think about it. Your GPS finding the fastest route, that's just an algorithm taking all the roads as input and finding the best one for an output.
A streaming service recommending a show you'll love? That's an algorithm analyzing your viewing habits. Social media feeds, email spam filters, your bank detecting fraud. They are all, deep down, just much, much more complex versions of the recipe we just built together.
And that leaves us with a final thought to chew on. If a simple little recipe like ours can reliably find the largest number every single time, what other problems, what bigger problems, could we solve if we just took the time to break them down into a clear, logical set of steps? The possibilities, well, they're pretty much endless.